Download this code from codegive.com, link in the description below. Creating a model checkpoint for a stable diffusion model using LoRA, low-rank adaptation, for generating AI art, such as PixAI art, involves several steps. In this tutorial, we will cover 1. Understanding stable diffusion and LoRA, brief overview. 2. Setting up the environment, installing necessary libraries and tools. 3. Loading a pre-trained stable diffusion model, using a base model. 4. Implementing LoRA, fine-tuning the model. 5. Saving checkpoints, storing the model for future use. 6. Generating art, using the fine-tuned model to create images. 1. Understanding stable diffusion and LoRA. Stable diffusion is a deep learning model for generating images from text prompts. It's based on a diffusion process that transforms random noise into coherent images. LoRA is a technique for efficiently training large models by adapting only a small number of parameters, making it useful for fine-tuning without requiring the full model capacity. 2. Setting up the environment. Make sure you have Python and pip installed. Then, install the necessary libraries. You can use the following commands. Bash. Pip install torch vision torch audio transformers diffusers accelerate. 3. Loading a pre-trained stable diffusion model. You can load a pre-trained stable diffusion model using the Hugging Face diffusers library. Python. Import torch. From diffusers import stable diffusion pipeline. Load the pre-trained stable diffusion model. Model_ID equals compvis/stable diffusion v1-4. Pipe equals stable diffusion pipeline. From _pre-trained, model_ID, torch_type equals torch.float16. Pipe.to, CUDA, move the model to GPU for faster inference. 4. Implementing LoRA. To implement LoRA, you will need to modify the training setup slightly. Below is a simplified example of how to apply LoRA to a stable diffusion model. Python. From peft import get_peft_model, LoRA config, task type. Define LoRA configuration. LoRA_config equals LoRA config. R equals 16, rank of the adaptation. LoRA_alpha equals 32. LoRA_dropout equals 0.1. Target_modules equals to_k, to_v, specify target modules for LoRA. Task_type equals task type.seq_2_seq_lm. Wrap the pipeline with LoRA. LoRA_model equals get_peft_model, pipe.unet, LoRA_config. 5. Saving checkpoints. After fine-tuning your model, you need to save the checkpoints for future use. Python. Model_save_path equals ./LoRA_model_checkpoint. LoRA_model.save_pre-trained, model_save_path. 6. Generating art. Finally, you can generate images using your fine-tuned model. Python. Load the model from checkpoint. From diffusers import stable diffusion pipeline. From peft import peft model. Load the LoRA model checkpoint. LoRA_model equals peft model. From pre-trained, model_save_path. Set the model pipeline with the LoRA model. Pipe equals stable diffusion pipeline. From pre-trained, model_ID, torch_type equals torch.float16. Pipe.unet equals LoRA_model. Generate an image using a text prompt. Prompt equals a fantasy landscape with mountains and rivers. Image equals pipe, prompt, images 0. Save the generated image. Image.save, generated_art.png. Conclusion. In this tutorial, you learned how to implement a model checkpoint using LoRA for fine-tuning a stable diffusion model aimed at generating AI art. This process allows you to efficiently adapt large models for specific tasks while retaining the ability to save and load checkpoints for future use. Additional notes. Ensure you have a GPU for faster training and inference. You can experiment with different parameters in LoRA to achieve various results. Always review the licensing agreements for any pre-trained models you use.